Hello and welcome back. Today I'm going to try to do day 2 of Advent of Code 2023. As you can see, it's already December 5th. These past couple days I've been busy and also been sick. I just took my cough medicine, so hopefully it's good enough. I didn't even go to work these past couple days. And tomorrow is an office day, so I really want to be better now. I've used up all my sick days because I've been sick so much this year. Anyways, let's get started. Day 2, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Okay, cubes, 3 colors, and you don't know the amount of cubes. Okay. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in game 11. Okay, followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. Oh, but there's no semicolons. Okay, there's subsets, I see. Okay, for example, the record of a few games might look like this. In game 1, 3 sets of cubes are revealed from the bag, then put back again. The first set is 3 blue cubes, 4 red cubes. The second set is 1 red cube, 2 green cubes, and 6 blue cubes. The third set is only 2 green cubes. The elf would first like to know which games would have been possible if the bag contain only 12 red cubes, 13 green cubes, and 14 blue cubes. Do we reuse the cubes or no? In the example above, games 1, 2, and 5 would have been possible if the bag had been loaded with that configuration. However, game 3 would have been impossible. 20 red, yeah. Because at one point the elf showed you 20 red cubes at once. Similarly, game 4 would also have been impossible because the elf showed you 15 blue cubes at once. If you add up the IDs of the game that would have been possible, you get 8. To determine which games would have been possible if the bag had been loaded with only red cubes, 13 green cubes, and 14 blue cubes, what is the sum of the IDs of those games? The question is, can they be reused? Did I miss that clue somewhere? So you said games 1, 2, and 5, because 3, 6, and 9. So games 1, 2, and 5 would have been possible. But do they add up together? They never have been said. 3, 2. You put them back into the bag. Okay, so you're always reused. A few times per game. Okay, that makes sense. They can be reused. So all we have to do is check the number. And if it's greater than, check the number of each subset. Is it here? No, each subset is like this. Separated by semicolons. And then compare it with the total number of cubes here. respectively. And if it's greater, then it's impossible. And that's that. Because we can reuse it. That was the key piece of information that I was searching for. Alright. How do I... Okay. New Python file called day2. Sure. Then we got the day2 sample. Don't ask again. Okay, let me get the sample ready. And let's copy everything from day 1 to day 2. And we're just going with the day 1 sample. Day 2 sample. Let's change everything. Come on. Day 2. That. So, ever input list. Okay, the delimiters will have to be different, but good thing that my helper function already accounts for the delimiter being different, but it may not account for other delimiters. I have to figure out how to delimit this. I think I gotta use the semicolon as a delimiter. Or the colon as a delimiter, because then I split up the game ID with the information, and then from there it'll be one string, and then I will just split the string. No way. We don't need some. Do we need? Yeah, we probably need some for line in input list. Oh man. Alright, what is this? How do I even do this? Oh, it just already splits it. Okay. I see. I call it array. Interesting in Python. So input list. Would contain it would contain game ID and then the balls and colors. Great. So that helped already. To be honest, let me check my puzzle input. See how all this has game? I can actually just remove this and then convert. Just remove this game plus space. But in reality, we actually don't need this because I already have that information. It's in ascending order, and they don't skip a number. So whatever element plus 1 would be the ID. So I actually don't need to do any string modifications for the left part. So actually all I can worry about is here I would want to enumerate because I want that index with me, because index plus 1 is the line ID. So how should I name it? These are colors or cubes, subset, bag. I just call it bag info. Sure. Okay, you've already split it by the colon. And then we're gonna split this bag info again. So I don't know what to call it. Dot split, and we're gonna split it by the character semicolon. And then we can just honestly we can just print this. So, just make sure it's correct. Day 1, gonna be day 2. Okay. I'm doing part 1. Where's part 1? Here. I could just return this. It doesn't matter. What? I thought I changed everything. Day2 sample. Okay. No. This is an int object. A line is an int object. Am I screwing up this order? I haven't seen this. Like, what does this return? Well, whatever. So line is the object is the second element in the enumerate return. This is also wrong. What if I just print the input list just to see if my my helper function is doing it correctly. I'm stupid. I am stupid. Okay, I didn't even put this delimiter, but it's okay because what? Because the input is also, it's already split by new lines. See? There's a new line at the end. I thought everything was going to be one continuous line, and then I didn't imagine this correctly. Whoops, my bad. So actually, this is already split correctly. And then within each line, would split by the colon. And we only want the second one, the second element. So we split by the colon. And then we can split by semicolons. Maybe that is correct. 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. 6 blue, and 2 green. Is there space after the semicolon? There's a space always, so should actually split by this. It's easier to track. Oh no. Oh, this also needs space. Unread. Okay, there we go. That looks better. Okay, now I got the correct configuration for this, correct data structure configuration for this question. Oh man, I can now iterate through everything and then compare each number and each color with the given amount, which is 12 red, 13 green, and 14 blue. So here I would probably do that with the dictionary. Color to number. And we have blue. What do I need this? Probably not. I think I can just go blue num or number of blues. Red count equals 12. Green count equals 13. And then we got to iterate through every element for, I don't know, what do we call it, subset and bag info split. Subset split by the space here. Do we? Oh no, 3 blue, 4 red. We split by the comma. And every split would be the number plus the color. And then we split. I see. I remember why I used the dictionary. Let me think a bit. Color to number. Just call it blue. 15, 14. Red. 12. Green. 13. And then you iterate through the entire bag. And then for each subset, which is 3 blue, comma 4 red. You would iterate through number and color. Equals number and color dot split by the space, because 3 and blue, between that there is a space and there won't be any other spaces in the string, so I can do this. And probably convert this to int. And color. It's okay to repeat the split. Doesn't affect the program that much. And then if the number is greater than color to number, color. I just saved an if statement by using this dictionary here. Possible equals true. Break. If impossible equals true, break. Then we gotta initialize our impossible. If impossible, sum plus equal to line index plus 1. Then we reset impossible to false, and we continue to just return the sum. Alright, let's see. I didn't test it out along the way, so I don't know where I made a mistake. That cannot be right because the sum return has to be outside 7. So now 125. I'm off by 1. I don't think this does anything. Okay. 14, 12, 13. Is that correct? Blue, green, red. Okay, that's correct. Let's debug. So we have 3, 4 blue, red. 3 blue, 4 red. So it's only 3 blue now. 3 blue. This should not be impossible. Oh, it has to be if not impossible. It's lowercase, yeah. If it's not impossible, then we add because that's valid. I didn't understand the question correctly. We need possible, right? Okay, that makes sense. Should be 8. That's correct. I didn't copy paste this yet. Can copy paste the actual text input. day2.text. Then I just flip this. Let's try again. 2771 is a sum. Is it correct? No, easy. Okay, part 2. The elf says they're stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewer number of cubes of each color that could have been in the bag to make the game possible? I see. I gotta consider the example games from earlier. Okay, there's no part 2. In game 1, the cube could have been played with if used 4 red, 2 green, and 6 blue. If any color had 1 fewer cube, the game would have been impossible. Game 2 could have played blah blah blah. The power of the set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. If the power of the minimum set of cubes in game 1 is 48. In games 2 to 5, it was 12, 1560, 630, and 36 respectively. Adding up these 5 powers produces the sum 2286. For each game, find the minimum set of cubes that must have been present. I mean, basically, you just find the highest number. So, like, highest is blue. Here, highest are red. 4. Green is 2. Well, let me think a bit how to do this. We definitely don't need this. We don't care about 14, 2, and 12, and 13 anymore. Okay, all the splitting is correct. It's only when we come over here for each... I don't care about impossible anymore, I think. Got a min red count, min blue count. Then we have a min green count. Subset. Well, I said we didn't do this. But maybe I keep this dictionary here. I just don't like these strings. Way too many if statements. If that's greater than that, this thing equals number. Is that it? Huh? Has to be greater than, yeah. Okay. Then we don't have sum anymore. Oh, we sort of do. We multiply 4 times 2 times 6, 12. Times 4. Okay, you multiply everything together. So we have power. So we have a sum, but is there a multiple? Alright, multiply list. Is there a built-in function? Is my I just don't believe there is a built-in function for this. Nah, screw it. Like we could just do this, honestly. Red. Then you multiply by green. And that you have the power. So that's the power, and you return everything. Okay, let's test it out. Why, man? Part 2, then we need the sample first. 2286, which is correct. And then I want the true puzzle input. Hey, what's wrong with this? I keep misclicking. Shift and space are just right or shift and enter are right next to each other. Alright, let's try this. 70924. Is that correct? Alright, cool. That was pretty. And I finished day 2. That was pretty good. Didn't spend too much time debugging, and yeah. We completed this quickly. Nice. Well, that concludes Additive Code 2023 Day 2, and see you next time.